We're going to do a quick review of all of the algebra and all of the geometry of the trigonometric functions that we have. So we start off with a point xy on the plane that's not the origin. We have a distance r from the origin to that point, and we have an angle theta that this creates. That gives us the 6 basic definitions for trigonometric functions. Sine is y over r, cosine is x over r, tangent is y over x, cosecant is r over y, secant is r over x, and cotangent is x over r. All these functions are for the specific value of theta that we get from this diagram. From this, we can then do a bunch of algebra to verify these identities. Tangent theta is sine theta over cosine theta, cotangent theta is cosine theta over sine theta, secant theta is 1 over cosine theta, and cosecant theta is 1 over sine theta. And then on top of that, we have the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. This came out of this picture by recognizing that the point xy lies on a circle of radius r. So x squared plus y squared equals r squared, and you divide through by the r squared, and you can relate this back to the sine and cosine functions. With this identity, you can then calculate these other 2 trigonometric identities by either dividing by sine squared theta or cosine squared theta. There's even more to the picture than this. And so what I'm going to do is I'm going to scoot over and draw a coordinate plane. And let's just think about this coordinate plane for a moment. Remember that we thought about where the sine and cosine functions were positive or negative. So we had cosine of theta was positive in the first quadrant, as was sine of theta. So both sine and cosine are positive in the first quadrant. In the second quadrant, cosine is negative, but sine is still, is still positive. In the third quadrant, they're both negative. And in the fourth quadrant, cosine theta is once again positive, and sine theta is negative. Knowing these relationships, it turns out that you can determine for each of the trigonometric functions where they are positive and where they are negative. Now, there is a quick mnemonic device for keeping track of this information. It goes like this. There are all sorts of different phrases you can use, but the typical one is all students take calculus, going around from quadrant 1, 2, 3, and 4. All are positive in the first quadrant. Sine is positive in the second quadrant. Tangent is positive in the third quadrant. Cosine is positive in the fourth quadrant. And if it's not listed here, it's negative. So tangent and cosine are negative here. Here, sine and tangent are negative. And then with the reciprocals, you can then find out the rest of these, whether these are positive or negative, based on the fact that when you take the reciprocal, the sign doesn't change. So if sine is positive here, that means that cosecant is positive here. And if tangent is positive here, that means cotangent is positive. And so all of this relates back to the geometry of the coordinate plane. The quadrants are determined by whether y is positive or negative. X and y are positive or negative in each of these quadrants, which corresponds to cosine and sine being positive and negative. Once you have those things, you just take these formulas right here, and you can just apply. So for example, tangent, if they have a sine is positive and cosine is negative, tangent will be negative because positive divided by negative is negative. So there you go. This is how all this information relates to each other. So let's do an application of this. If tangent theta is 2/7 and theta is in the third quadrant, determine cosine of theta. Now we can do this with an algebraic approach, or we can do it with the geometric approach. Let's start off with the algebraic approach. Tangent theta is equal to 2/7. Theta is in the third quadrant, determine cosine theta. So what does it mean to use an algebraic approach? It means that we're going to look at the identities and make substitutions to try to calculate the values. So the first thing that we may try here is use the fact that we have this Pythagorean identity, tangent squared theta plus 1 is equal to secant squared theta. Now we can see that this is going to be useful because secant is 1 over cosine. So these two are related to each other, and we know the value of tangent theta. So what we're going to do, we just plug it in. So 2/7 squared plus 1 is equal to 1 over cosine squared theta. 2/7 squared is 4 over 49, plus 1 is equal to 1 over cosine squared theta. we add these together, we get 53 over 49 is 1 over cosine squared theta. If we take the reciprocal of both sides, we get 49 over 53 is cosine squared theta. And from here, if we need cosine theta, we're going to take the square root. Cosine theta is equal to plus or minus the square root of 49 over 53. Now we have to do the plus or minus here because remember when we take the square root of both sides of the equation, we introduce that and we have to determine whether we want the plus or the minus. And to get that, we have to think about this third quadrant. In the third quadrant, the x coordinate is negative, which means cosine is negative, which means we want the negative sign here. So cosine of theta is equal to negative 7 over the square root of 53. And so this is the algebraic approach to determining the value of cosine theta given the tangent of theta. We're going to do the same problem again, except now we're going to do a geometric approach. So once again, if tangent theta is equal to 2/7 and theta is in the third quadrant, determine cosine of theta. So for the geometric approach, we're going to start off by drawing a coordinate system. Now theta is in the third quadrant, so we're just going to stick it out somewhere down here. It doesn't have to be exactly proportional, this is just getting the ideas across. And then we know that tangent theta is equal to 2/7. Tangent of theta, if we go back to the basic formula, tangent of theta is y over x, and we know that this is equal to 2/7. Now, you might immediately say, okay, so y is 2 and x is equal to 7, but that would put us in the first quadrant. And so in order to get this point into the third quadrant, we have to take the negative of both the top and the bottom, because negative 2/7 is the same as negative 2 over negative 7. And this gives us a coordinate, y is equal to negative 2, x equals negative 7, and that coordinate is in the third quadrant. So x is negative 7, y is negative 2. And so this point corresponds to our angle theta. At this point, we want cosine of theta. Cosine theta is x over r. Well, we have our x coordinate right here. But what we don't have is we don't have the r value. Remember, the r value is the distance from our point to the origin. Well, to get that, we use the distance formula. R is equal to the square root of negative 7 squared plus negative 2 squared. That's our x squared plus y squared. 49 plus 4 is 53, square root of 53. And so we can just plug it in, square root of 53. Now, the algebraic approach and the geometric approach are two different approaches to the same problem. It is not that one is better than the other, but in fact, it would be best if you can understand both ways of doing it.